And we'll go from current slide. Yes, here we go. Now, while we're waiting for the lights, cameras, and actions to happen, let's talk about some things coming up, announcement-wise. This week, up until Wednesday, they are going to be testing the fire alarm system on this campus, okay? Anywhere on this campus. So if you hear either in this building or another building, the fire alarm's going off, we hope that doesn't mean it's a fire. Do not respond as if it's a fire or even a drill. We're not supposed to be doing the drill. They've just got to check it. I think once a year it's a requirement to make sure the alarm system is working properly. So if you hear the alarm go off and no one comes around saying, this is not a test, this is actually a fire, if you hear that, then we proceed with fire, okay? But if you don't hear that, we're going to assume no fire, no drill, stay where you are, and that's anywhere on this campus today, tomorrow, and Wednesday. I think it's supposed to be finished by then. Okay, number 2, next week is Cougar Connection Week, and they have activities going on both campuses, Monday, Tuesday, Wednesday. On Thursday, it's mostly on the Birmingham campus, but there will be activities, programs, presentations, tables, opportunities for you to sign up to volunteer, opportunities for you to sign up to be a part of a campus organization. It should be a very good week. So take advantage, watch out for the tables and things going on. Now, one other thing, I don't know if any of you are math majors. Are you? Or even pre-engineering? Okay. Well, then it wouldn't pertain to you, but they are. Each department is supposed to send a representative to the coronation of Miss Lawson State. I haven't ever quite figured out why that's the case, but we are. But if none of you are math or pre-engineering, then I wouldn't need to know if you'd be interested in that. But if you are, and you want to talk with your advisor to see if you could participate in that in your department, you certainly are welcome to do so. They may have already chosen somebody I was supposed to have, but I missed the email early, and today's the deadline, but that's our problem, not yours. Okay. Hopefully, you didn't miss anything. All right. Now, that being said about the campus, where are we in this course? Okay. Well, fortunately, many of you, start off, 4 of you have already turned in your research paper. That's pretty good. I may have one class that may have done a few more, but not many. So you're all doing well on that, and I would say easily more than half of you have turned in your first quiz. Now, if you haven't turned in the first quiz, please try to get it to me today or tomorrow so there's a chance I can get it graded and back to you on Wednesday. Now, I can't return your quizzes to you until I get them all in, but anytime after they're graded, you're certainly welcome to come up and see what you missed, but I just can't return them to you until I get them all in. Otherwise, the correct answers are floating around out there, and someone's eyes may drift onto and see the correct answer, and that dilutes your grade and boosts their grade, which I don't think is fair. So please get your quizzes in, because remember, you got it ready now? I saw you flash it at me a time or two. Okay. If you, oh, good. Good. Thank you. Thank you. Because remember, you cannot take the first test until I have the first quiz in hand, unless you ask me politely to give you a 0 on the quiz. And if you ask me politely, I can't help but say, okay, sure. And I have to give you a 0 on the quiz. So please get your quizzes in, and preferably today or tomorrow so I can get them graded. You can see if you made any errors. Most of you, of course, didn't, right? But if you did, what those errors were. Otherwise, you're going to make the same error on the test. So that's why I'd love to have the quiz in today or tomorrow so you at least get a chance to see what you missed. Okay. Now, any questions on anything we've covered so far? The reason I'm saying all that, we should finish 10.5B today, since we only have a few things left to do in it, like 2 examples or something like that, maybe just 1. And then we will be ready for the test for the next time. And this is Pablo, right? Okay. All right, good deal. All right, any questions before we get started today? All right, we went over last time how you divide polynomials. Very, very similarly to how we divide big numbers, okay? By hand, long division. So let's divide, and when they say it this way, 6x squared, we didn't do this one last time? Or did we just get started on it? We did it. Okay, I think I know why the mark is here. We did it last time, okay? I thought I remembered that. Okay, I wanted to show you in certain circumstances, very limited circumstances, an easier way to do this. But let me go over again. First, what would be one of the first things we would do? Remind me. I know it's a long weekend since we last met. Okay, yes, you got to get them in descending order of the power. Both the divisor and the dividend. Which, by the way, when they write it this way, this part goes under the house, that part goes outside the house. Okay? Then the next step would be, after we get them in descending order and in the right places, what do we do next? Divide first term in the first term, right? Then we multiply. And then, this is the step I want to focus on. What do we do next? After we multiply that first part of the quotient by the dividend, write it down underneath the divisor, or at least that part of the divisor, what's the next thing we do? Subtract. And I suggested to you that once you get into signed numbers, like well, these are all positives, but once we get into signed numbers, the simpler way, to me, the more efficient way, to me, to do it with minimizing, to me, the chance of making an error with the signs is change signs and add. Right? Okay. Remember that. Change signs and add. And then you proceed. So I want to suggest or give you a shortcut for certain types of division problems. Now, most of you have probably had this before. Have any of you heard of synthetic division? Okay, I thought so. But a few of you may not have. Okay, so let's go over that real quickly. Not all problems can you use synthetic divisions. Here is the key. Now, I've never seen it written in a book this way. It's an easy way for me to remember. Maybe not for you. Okay? Look at the divisor. The first term in the divisor. It's required that the coefficient be 1 and the exponent be 1. If that's met, you can use synthetic division in this problem. If this was 2x plus 3, can't use it because the coefficient's not 1. If it was x squared plus 2, you can't use it because the exponent is not 1. But if your coefficient's 1 and your exponent's 1, then you can use synthetic division. Okay. Now, the first step in synthetic, well, okay, we'll come back to that in a minute. I'll put it this way. The first step, then, is to write down what's outside the house. You draw the house, or I do a little differently now. I draw it like this, okay? Let me get my pen. Okay, I draw it like that. Now, what I put in that little thing is the opposite of the constant term. Why the opposite? What was the third step after we divided, multiplied, and then we subtracted, which is change signs and add? So since you're only dealing with this one thing, let's change the sign here, and then when we multiply, we'll add, and it works out every time. So we change the sign there and make it a -2. Okay. Next thing, sort of inside the house, we put what? Anyone know? Y'all seem to be familiar with it. Just say it. Say again. Someone said something. I thought we did. Maybe you never mind. Okay. You put the coefficients of your dividend in order of your decreasing order of powers. So what's the first coefficient we'd put? 2. The next one? 0. Why? We're missing a term here. Look at your exponent. 3, 1, 0. Oh, we're missing the 2. So where there should be a 2, we put a 0. Okay? 0 for the coefficient. Okay? You did that when we were doing it long way too, remember? We put 0x squared. Put a 0 there. Next, 6. Next, 26. Okay? Now I do this other little dumb thing. I always go back and count the numbers we have here. How many we got? 4. What's your maximum exponent? 3. You'll always have one more number here than your maximum exponent. Always. If you don't, check and see if you didn't skip a term somewhere. Okay? Or you put something in twice. Okay? You've got to have that just one more than your maximum exponent. All right. Now, the next rule I have is one I've never seen in a book either, and it's really dumb, but skip a line, draw a line. Okay? Really dumb, huh? Skip a line, draw a line. Now, anyone know what we do next? Bring down the 2. And then from this point on, it's the same step over and over and over again. Multiply, because that's sort of like dividing, but you multiply, that gave you -4. And then since you already changed signs, you just add, that gives you, y'all are stuck on -4, aren't you? Okay. Next. +8 multiplied, -2 times -4 is +8, and then we add, and that gives you 14, and then you multiply, and that gives you -20, what'd you say? 8, got it. Then you add, and that gives you -2. And here I put another little L bracket separating it. Why did I do that? Say again? That's what? Okay, kinda. This is when you divide, what's your answer? When you divide, what do we call the answer? That's a divisor, dividend, a Q word. Quotient, of course. And this might, okay, sometimes it's all right. Okay, you need to practice, it's fine. Okay, now, what is this called? Yeah, remainder. That's why I separate it like that. Okay, but the trouble is, we don't have any variables. Remember, we took them all out. So now we got to put them back. So what are the variables in here? How do you do that? You write down the 2. I got that part. Now, reduce your maximum variable, the power by 1. So that becomes x squared. Next. -4x. Next. Plus 14. And then there's a couple different ways you can write the remainder. You could put r equal -2 or something like that. Or you could put -2, the minus went with the 2, over your divisor, x plus 2. That's another way you could write it. Just like we did way back when you put your remainder over your divisor. Okay? It gave you a fractional form. This gives you a rational expression. Okay? Now, let's see. I know it was a long time ago, last Wednesday. What do we get as an answer? We got, there it is, up top. No, it isn't. Here it is, down at the bottom. Somewhere, yeah, there it is. That's a different problem, isn't it? Wait a minute. Oh. We did the one at the bottom. Sorry. What we didn't do is the one up higher. But we already did the one at the bottom, and that gave us, I'm sorry, I got lost again. Okay, a 2x squared, if you look at the bottom of page 20, 2x squared minus 4x plus 14 minus 2 over x plus 2, just like we did. Now I see why I had my mark at the top of the page. They skipped this one in the slide set. Y'all were supposed to remind me of that. And you didn't? Shame on you. Okay, never mind. I'm just kidding. Oh, okay, yeah. Yeah, that's what my job is, right? Okay. Okay. If I'm not mistaken, this is the same answer they got before. Let's just prove it to you, okay? I'm going to scroll through this. Ew. I guess I'm going to have to erase it. They just wrote the answer down. Okay, good for them. 2x squared minus 4x plus 14, exactly what we got. Laurent is here. Something like that. Okay. How badly did I mess it up? Okay. It was pretty bad, I can tell. Okay. With a remainder of minus 2 written this way, or the other way is 2x squared minus 4x plus 14 minus 2 over x plus 2. Just the same as we got. Okay. And that was the last slide. What I didn't realize is they skipped the objective 5B. They don't even number it. It just was an example at the top of the page. So let's go down and do that one. Okay? We'll do it here. That's why I had the mark at the top of the page. It says divide x squared minus 5x plus 8 divided by x minus 3. And they put everything in parentheses, which is probably a good idea. Okay? Which way you want to do it? Oh, y'all are taking all the fun out of it. Okay? How do we do? Does this qualify for synthetic division? Yes. Why? Excellent, of your divisor. Excellent. So what do we put outside the house? Positive 3. Y'all are good. Next, what do we put inside the house? A little louder. 1. All right. Negative 5. 8. Done. Okay. And then what do we do? Skip a line, draw a line. Y'all, you forgot my rule, didn't you? Okay. Now, next. Bring down the 1. Then. And what you get? Then. Negative 2. Then. Negative 6. Then. Positive 2. And you separate that. That's your remainder. What's your answer? Say again? You may have said it right. Maybe you didn't.
1x minus 2 with the remainder of 2.
A little louder.
1x minus
Okay.
2 with the remainder of 2.
X minus 2 with a remainder of 2, or how the other way you could write it? Plus 2 over x minus 3. Either way, it would be perfectly fine. I think that's how they wrote it in the book. Yeah, look at them. They got it right. X minus 2 plus 2 over x minus 3. And they did it long division. And guess what? They got the same answer. Okay? So, remember, you can't do all your problems with synthetic division. Just those that met the criteria. Okay? Does anyone need to see it done with long division? Okay. He's good. Okay. So, homework exercises here. Now, after a lot of these, not all of them, the ones that say focus on dividing two polynomials, the first one didn't. That's why they didn't have it on the slide set. But check your understanding 3. I told you before, good thing to do. I'd say as soon as we get out of class that you have free time, do your check yourself. Okay, check your understanding. And then you have your objective 10.5B practice problems. 4 of those, do those. And you'll notice the solutions are given coming up. And that's the rest of Module 10 are your solutions to these sections. Section 10.1, A and B, however many we had, 10.2, 10.3. And they have your check your understanding. They have all those done, yeah, as well as, okay, these are all the check your understandings, okay? That's what I'm saying to begin with. Then that's in all 5 sections. And then they have solutions to objective practice problems. And that's at 10.1A and B and 2A and 2B, all the way down through 5B, okay? Done. Any questions on Chapter 10? Module 10, sorry. Now, that means test time on Wednesday, okay? So come ready to take your test on Wednesday. And a couple of things here. Number one, we'll try to get started right on time so I can give you your full time, but I always do allow at least some time right at the very beginning for questions. So especially if you have some questions like between that now and then, you ran into some things that, goodness, I can't remember how to do this, and you went back and checked everything, can't come up with it. Try to come a little early, and I'll try to be here early, and I'll see if you have any questions, and I'll work as many of those as I can. I don't want to chop off too much of your time. So I definitely don't want to get started any later than 8:45. I want to give you at least a full hour. But if we can get started earlier, that would be great. You have more time. Yes, and the thing is, anytime you want to see your quiz, they're graded, they're on Blackboard, you can come see it. Right after class, anytime during my office hours. I have office hours from 2 to 6 today. So, yes.
How many questions do you
I usually shoot for at least about 20. Okay? Notice your quiz was 10, 1 page. Usually your test is going to be 20 with 2 pages. Now, it doesn't split out evenly, but some of those will be on the same thing that the quiz covered, and then some will be on the material we covered since the quiz. Because the quiz covered like the first half of the module, approximately. A little bit more. So I'll have some questions on that and some on this. So that's why I want you to see your quiz answers before you take your test. So come by anytime, again, right after class or during office hours if you want to see your quiz. Okay? Good deal. Any other questions? Okay, here's the other thing about the test. Now this I do for every test except the final exam. So for every test, in fact, even for the final exam, I encourage you to write out a formula and equation sheet. Whatever you want to put on a piece of paper, front and back, written as tiny as you want to do it. I'll even let you bring your magnifying glasses to the test. No, I'm sort of getting carried away. You can, but write down anything you want to on a piece of paper, and you can have it with you during the test. Okay? I do not think that math is a memorization thing. If it is, 3 weeks after it's over with, you've forgotten. It's gone. I mean, short-term memory. It gets. Y'all probably are way too young to remember Etch-a-Sketch. Oh, someone remember it? You can draw all these intricate pictures, and when you're through with it, turn it over and shake it. It's gone. Okay, that's how I won't want to say students' minds are in math, but you get shaken a little bit, they're gone. Okay. The other issue is this, to me, is the best way to study for a test. There was seldom an opportunity when I was an undergraduate that the professors gave us the possibility of bringing in a formula and equation sheet. But occasionally, I found one who did, usually upper level classes that were really complicated. He said, oh yeah, I'll bring you in whatever you want to on a piece of paper. Oh boy, the night before I was figuring out how to organize this stuff and put it down and getting it written so I could read it, but then in some sort of order so it made sense. I could find it easily. I spent a lot of time getting that sheet done so it was handy, clear, concise, had the important stuff in it, and the next day during the test, I'd forget to look at it. Because I found out after I had done all that, I knew the material really well. Okay? So I would say on every test you ever take, do that. Do a formula and equation sheet. Now, if the instructor or professor doesn't allow you to use it, don't bring it in the class and cheat. But it's the best study tool I think I've ever run into. And I got it in the course, they let me have it, and I didn't need it. And if I had done that in the earlier courses, So I let you do that for every test except the final exam. Because in Math 100, it's been the tradition long before I was here, it's been a while, that the Math 100 course is a departmental final exam. And being so, since the other instructors don't necessarily allow their students to bring in a formula and equation sheet, I can't allow you to do it either. But I'm not saying don't make up one the night before. It's still a good idea. It's still the best study tool that I know of. Just you can't bring it in during the final, but you can every other test. Is that okay? All right. Now, that said, any questions? All right. So let me get out of this and out of that, and we're going to 11.1. All right. The last bit of stuff that we were doing in with polynomials, basically multiplying and dividing, right? We did scientific notation in there too, but we multiplied and divided. Here we're going to do something they call factoring polynomials, okay? Now, I'll later talk with you about factoring in general, so now we'll just take it as it is. Basically, factoring polynomials is a lot like dividing polynomials. You're undoing the multiplication we just were doing, okay? It's like dividing, okay? So keep that in mind. Seldom do they mention that in the text. I think they ought to. All right. We're going to start with the first thing you should ever do when you're factoring is look for common factors, okay? So our objective, 11.1A, is factor a monomial from a polynomial, okay? Monomial meaning one term. Polynomial usually many terms. Could be one, but it could be. We don't usually. Oh, never mind. Okay. So something I bet you all remember from the past: greatest common factor of two or more integers is the greatest integer that is a factor of all the integers. Okay. So 24. What's the 24 and 60? Two integers. What's the greatest common factor of the two? Or give me any common factor of the two. Any factor that's common to both 24 and 60. 12. Hey, very good. Is that the greatest common factor? I believe probably so. Okay? You hit it on the nose. I was thinking someone would say 6. That is a common factor. It's not the greatest common factor because you divide 6 into 24, what do you get? 4. And if you divide 6 into 60, 10, well, you still have a common factor between 4 and 10. What's that? Between 4 and 10. Common factor. 2. And then 2 times 6, sure enough, is 12. So, y'all are good at this, okay? How about this? Now we have more than just numbers. The greatest common factor of two or more monomials is the product of the greatest common factor of the coefficients and the common variable factors. All right, so here we have 2. 6x cubed y and 8xy x squared y squared. What's the greatest common factor between 6 and 8?
2x squared y.
Say again?
2x squared y.
Oh, good. Y'all going right to it. 2x squared y. You are great. Excellent. Everybody see that? Greatest common factor between 6 and 8 is 2. Greatest common factor between x squared and x cubed is x squared. Greatest common factor between y and y squared is y. Okay. Now, note that the exponent of each variable in the greatest common factor is the same as the smallest exponent of any of the monomials. Just because it says greatest common factor, it's not the greatest factor that's in there, it's the greatest factor that's common to both of them. And that can't be any more than the one with the smallest number. That is only there once, so this one, the greatest common factor, can't be more than once. This is there twice, can only be up to 2. Okay, does that make sense? Y'all seem like you know it already, okay? Know it all, so okay, never mind. Okay. They're skipping a focus here, so let's go back. Yuck, they don't give you any room. We'll do it on this one. Let's drop the most. Let's see. Yeah, let's do it there. Okay, find the greatest common factor of, got to get my pen back. 12 a fourth b and 18 a squared b squared c. Okay, we want the greatest common factor between those two greatest common coefficient number. 6, you're absolutely right. First variable, a squared, excellent. Second variable, b. Third variable, not common to this one, so it's not common at all. It's c to the 0th power, which 0 to the 0th is 1. No, don't even do that. Okay, that's the greatest common factor. Make sense? All right, good deal. I thought y'all knew this already. Okay. And there's a check your understanding 1, and please do that as soon as you get out of class. Unless you have a question about it now, I'll go over it now. Y'all seem like you're on top of it. Anyone want to see another one done? Okay. All right. Then we get to this slide. We're going to factor a monomial from a polynomial. The distributive property is used to multiply factors. And remember what undoes multiplication? Or factor. Factoring undoes multiplication. The distributive property is used to multiply the factors of a polynomial. So to factor a polynomial means to write the polynomial as the product of other polynomials. So in other words, if a times b is equal to ab, then ab is equal to a times b. So you either do it this way if you're distributing, or this way if you're factoring. So that's what we're doing. So here we have a, boy, did they ever, oh, let's do it. Let's start with this. Polynomial, 2x squared plus 10x. What's the greatest common factor between those two integers? 2x, you got it. So factor that out, and what do you have left? X plus 5, and there you factor. Everybody see how that works? Okay, you're already here, right? Okay. Okay. In this example, 2x is greatest common factor, so we undistribute it. Okay, we pull it out and write it as a distribution issue. Okay, greatest common monomial factor of the two terms, and x plus 5 is the binomial factor that's left once you factor out, pull out the common factor. Make sense? Now, in case any of you are real nitpickers, not that any of you particularly nit, I don't know, you say, well, 2 and x are factors too. Yeah, they are, but monomials we leave together. If we could factor this one anymore, we certainly do. We don't yet. We will be doing it later. But this one, monomials you leave as a unit. So don't go to the extra effort of showing that's factorable too. It is. Okay? So, here, focus on factoring. Greatest common factor from a polynomial. Let's do the A one first. You see any common factors at all? How about numerically? 5. How about variably? X. What do you have left? X squared. Anything else? Help me, I'm dying here. Minus 7 x plus 2. And guess what you can do to check this? Multiply, distribute, and see if you get the same answer. 5x and x squared, 5x cubed, perfect. 5x times negative 7x, negative 35x squared, 5x times 2, 10x. Yes, it worked. Okay? I tend to like to always check my answers because I find I make a lot of mistakes, and that way I can catch my mistakes. Okay? All right. How about the second one? Say again? Okay, I heard 4 is the greatest common factor for the numerical part. Next, x squared. That sounds reasonably good. And then, y. Why not? Okay, and what do we have next? What's left over? 4. Okay. Next. Plus 2 x squared, y, minus 3 x squared, y to the 4th. Did I hear? All right. Now, okay, I forgot to say this earlier. Let me say it now. There's a couple things I usually do. One, before I even check it. I told you about checking before. I'll look at what's in here and see, have I missed any common factors? And quite often I have, okay? There may be one that I didn't see was common, but this has a 4, that has a 2, that's common, except 3 is not common, so nothing there. And then there's no variable here, so there can't be any common variables. Even though these 2 are common here, you don't have one there, so there's nothing more you can do, that's it. Except for checking it and going back and multiply through. I'm not going to do this every time, but not a bad idea to do. Especially on quizzes, okay? On quizzes, you got plenty of time to check those answers. Do it, okay? On tests, wait till the end and you get everything finished, and before you turn it in early, check as many as you can. Make sure. You know what? Correct answers are a lot easier to grade than wrong answers. And I'm really lazy. I want you to get as many right as possible. So it makes it easier on me. Okay? Deal? All right. So check as many as you can get away with. Okay. Let's see how they did it. All right. The first one, greatest common factor is 5x. We agree. Okay? And when you factor that out, oh my goodness, look how they did that. Okay? They divide out the 5x out of every one of the terms up there. 5x cubed divided by 5x is x squared. I really write this down every time, yeah. But if it helps you, do it, by all means. Negative 35x squared divided by the 5x is negative 7x, okay? And 10x divided by 5x is 2, the x's go away, okay? So there you have the components of your polynomial. So we write that down as, we write down 5x cubed minus 35x squared plus 10x again, because we like writing down stuff. And then we factor each term separately. I really do this every time. And then we factor it out, 5x times x cubed, x squared minus 7x plus 2. But guess what? If this helps you see it better than what I said, or what the other people said, do it, okay? Do whatever it takes to make sure you get the right answer. Remember, I want to grade right answers, okay? That's your purpose in life, to get as many right as possible so I can be as lazy as I want to be, okay? It helps me move faster, okay? And I'll move awfully slow, so. Any questions? All right. Is it Saya? Okay. Okay, y'all playing tag team here? No, okay, no problem. Okay. All right. Any questions on this? All right. You can do it their way. You can do it some modification of their way. Do it however you want to, as long as all the steps are right and you get a right answer. I'm a happy camper. Okay? Here's how they did the B. And by the way, this is not a bad idea to do, and this is how they're going to do that first term in B. Okay? They get 16x squared y. Okay? Since these are some big numbers in this one, they factor this 16. Now, y'all know what prime numbers are. Tell me what a prime number is. Say again? Okay, that's a composite number. What's a prime number? Say again? Okay, that's 1 except for 1. There is a prime number that is divisible by 2. 2 is divisible by 2. That's the prime number, but it's the only even prime number. So I know you're getting at the right thing. Okay, but what is a prime number? A number that is divisible only by itself in 1. That's the only factorization you have. That's a prime number. So what we usually do is start with the smallest prime number, 2, and say, will 2 go into 16? Yes, it will. How many times? 8. So I'll put a 2 here. And 8, will 2 go into 8? Yes, it will. So I'll put down another 2. How many times? 4. No, 4. 2 into 8 is 4. Okay. All right. Will 2 go into 4? Yes, it will. How many times? 2. All right. So we get 4 2s here. Okay. And then they could have done the same thing here. Will x go into x? Yes. X times x, and then y. So they did the prime factorization of this. They didn't string out that one. Okay. Fine. Then they do it for the next term. Just as a review, this next term was 8x fourth y squared. Okay? So, on that one, they did the same thing. Smallest prime number is 2. Will 2 go into 8? Yes, it will. How many times? Will 2 go into 4? Yes, it will. How many times? 2, and 2 is prime, so you got the prime factorization of 8. And then they put down x4 and y squared. You could have done x times x times x times x and y times y, you know, but you don't have to, but they didn't, okay? And then they do the same thing for that last one. Prime factorization of 12. What's the smallest prime number? Oh, yeah, 2. Will 2 go into 12? How many times? 6. Will 2 go into 6? How many times? 3. Is 3 prime? Yes, there's no other number going to 3. So 2 times 2 times 3. There's your third. There's your prime factorization of 12. And then they put down the x fourth, y fifth. Okay? So, to get the greatest common factor of these 3 terms, you look at what's common to all of them. 2 times 2. Common to every one. That's where the 4 came from. Okay? Once you took that out, that left you a 4x squared y, a 2x blah blah, and a 3 this. Okay? Those were your coefficients we have. Okay? Now, we do the same thing with the x's. Greatest common factor here is x squared. So you didn't have any x's left there. X squared here, x squared there. Greatest common factor of the y's, the y. You had a y left here and a y fourth here. And that then produced the greatest common factor of 4 here, x squared from there, and y from there. There's your greatest common factor. And then you proceeded as before. Oh yeah, by doing it this way. If you want to. If this helps you see it, by all means do it. Divide that greatest common factor into each of the terms. Okay? They didn't do it for the last one, did they? Why not? I don't know. Okay? Maybe they do it on the next page. I'm a little confused here. There it is. There. Yeah, they left off the sign on this one, so they put it in down there. Okay, fine. Okay? And that gave you what the remaining polynomial is, 4 plus 2x squared y minus 3x squared y fourth. And they wrote it out. This again, I keep forgetting they do another step. And then they finally get 4x squared y times 4 plus 2x squared y minus 3x squared y fourth. Okay? Several different ways you can approach these. Do whatever makes the most sense to you, as long as every step is right. I don't want you making up new rules, okay? I make up the rules, you just follow them, right? Okay, no, it's been done a long time. Okay, whoa. That's it for 11.1, okay? There was your check your understanding 2 on module 11, page 3, okay? There are, okay. There's another check your understanding. Do those shortly after you get out of class, as soon as you can. And then the practice problems, there's 5 of those. Do those 5. Now, I haven't said this before, or maybe I have. If any of you are in those, what do they call them? It's the tutoring sessions. If you're in those and they don't give you something to do, this is what you do. Do your check yourselves. Do your practice problems. Okay, do as much of this stuff. In other words, do your homework. Okay, now don't wait and do your homework there. If you don't have that until Friday, go on and do all the ones up till then on Friday do the ones that have been assigned for that. But that's, if they don't give you something to do, that would be my suggestion of what to do. All right, I don't know how they run those. We just started doing them. So let's move on to objective of 11.1b. Okay, so we have to get out of here and discard that and get rid of that. I just love spending all this time changing these slides and pointing out, wow, we got a full 7 slides this time. That's going to be so exciting. Okay, so we will go to the slideshow from the current slide. And this one we've seen before. I'm glad they they put this in again, factoring polynomials. But 11.1 is common factors. We saw that one before, so now we got, that's 2 of our 7. That gave us nothing new. But the new objective, 11.1b, factor by grouping. That's not grouping. Never mind, never. Just factor by grouping. Now, in the examples below, the binomials in parentheses are called binomial factors. Okay, they didn't show us the original problem. You could distribute and see what it was, 2a squared plus 2ab. When you factored out the 2a, you had a binomial. And this one was a 3x squared y minus 3xy squared. Factor out the 3xy, and you had left a binomial factor. Yeah, nothing new there. 2-term polynomial is called a binomial. The distributive property is used to factor a common binomial factor from an expression. Yes, I just showed you how to do it. Now, here's what we're going to do. In the expression at the right, we got something that's a little different here. Here we have x times y minus 3 plus 4 times y minus 3. Is there a common factor there? What? The y minus 3. The binomial can be a common factor. Okay? Now, you had to factor to begin with to get to this step, but when you got there, you see the common factors here. So what do? Factor out the common factor and write what's left. That's what we did before, isn't it? When we factored out a monomial factor, same thing here. Pull out the common factor and write what's left. Okay? So in that expression, the common binomial factor, the common factor is y minus 3, and when you pull it out, what you have left over is x plus 4. Okay? Now, sometimes a binomial factor must be rewritten. Sometimes it must be rewritten before the common binomial factor can be found. Okay, they just put that statement there. I think we'll see an example later. Some polynomials can be factored by grouping the terms so that the common binomial factor is found. So that's what we're going to do. Let's see how to do that. All right? Now, it says grouping. Now, before you group, it's just like with our division. Because isn't this a lot like division? A good idea to write it in descending order of the power. Remember, y'all did that before. Both of these are done that way, so we don't have to do anything. So, first guess. May not work, or it may work. Let's group. Whoop, let me get my pen reactivated. So let's just group those two together and those two together. Now, that's not a factorization. That's just grouping. Okay? Now, let's look at the first group. Is there a common factor between 2x cubed and 3x squared? What is it? X squared. What's left? 2x minus 3. Y'all are good. Plus, is there a common factor between 8x and minus 12? Bigger. Okay, let's go with 4. Plus 4. Now, if you did 2, it would work, but then you see there's still going to be another 2 in there, so pull it out. Okay, so 4. And what's left? When you factor out of 4 out of 8x, 2x, and 4 out of minus 12, negative 3. Are there any more common factors? Yes, the binomial is a common factor. So let's factor that out. 2x minus 3, and what's left? X squared plus 4. Now, later in your life, as in a week or so, or maybe not even that long, we'll always look and see, can I factor that any further? This one you can't. I'll just tell you right now you can't. But a little later on, we'll always, once we factor out someplace, say, is there anything else? Just like if she had really factored out only a 2, when you get what's left, it's not a common factor, you say, hey, is there something else there? Yeah, there's another 2. 2 times 2 is 4, and then you wind up with that. So always look at what you have left to see if there are any other common factors that you can go any further. Okay? Make sense? All right. And that, folks, is your answer to A. Let's see what they got. Well, let's go on and do B. Okay, what would be your suggestion of what we do here? Okay, did I hear you group them together? Okay. Now, here's a little bit of a problem. When it's a plus in between there, I don't put that in the grouping. When it's a minus, you have to put it in the grouping. But that looks like it's a product now, doesn't it? It's not. It's still just grouping. The parentheses are only there for grouping purposes. And what do you look for next? Common factors in the first group. Are there any? What is it? Y squared. What do you have left? 3y minus 4. Okay. In the second group, are there any common factors? Say again? A negative 2. That's why I included the minus sign. Include that here too. Minus 2. What's left? 3y minus 4. Aren't y'all good? You got your signs right. Those signs will sneak up there and bite you where you don't want to be bitten. So please watch your signs. Okay? That's like a base runner. You better watch the signs. Yeah, never mind. Okay. Next. Can you do anything else? Say again? Oh yeah, a common factor of 3y minus 4. Keep going then. 3y minus 4. And what's left? Y squared minus 2. And later you'll always look and say, can I take that any further? And right now I'll tell you, no, you can't on that. In the future, there will be some that will sneak up on you and you have more factoring to do. Always factor as far as you can. Right now, that's as far as you can. All right, want to see how the book did them? I mean, the slide set did them? Okay, this may, yes. Any questions? No questions? Okay. That's messy. Let me erase that. I was afraid that'd be the case. All right, let's get back there. All right, first thing they do, they wrote it down again, which is an excellent thing to do if you want to waste time. Okay, write them down again. And then group. And you try any grouping. I usually do the first obvious one. Sometimes they won't work and you have to rearrange and try something else. But when you group these two and those two, you look at that and say, are there any common factors in the first group? Just like we found. Yes, there's an x squared, leaving us a 2x minus 3. In the second group, there's a plus 4, leaving us a 2x minus 3. We feel really good about that because the common factor is now 2x minus 3. And you factor that out, you're left with x squared plus 4. That's your complete factorization. Oh, and I forgot this too. Is there any way to check that? Curse is foiled again. Yes, you foil it. Okay? 2x times x squared is? 2x times x squared is? 2x cubed. Ding, 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 ding. 2x times 4 is? Plus 8x. Ding, ding. Okay? Enter. Minus 3 times x squared, minus 3x squared, and last, minus 12. Got it. Done. And if you have a chance, go back and check, always. Why? Because you want it to be easy on me, right? You want to get them right. Let's go on to the B part. Any questions on A? So let's go to the B. We group, okay? And that was a common way of grouping. Now, notice how they grouped a little differently than I did. They grouped these two together. Then they pulled out the minus sign, and in the second group, that's where they changed the sign. I grouped them and then later pulled out the minus sign with the common factor. They did it separately. When you do it this way, and it's fine, it's perfect, it's a very good way to do it, remember to change the sign inside. Because that minus sign change this. This is plus now. It's minus up there. This is minus now. It's plus up there. So be sure, if you do it this way, be sure you change the sign of both terms in the group. Okay? Good way to do it. And then, what's your next step? Exciting stuff, isn't it? Common factor. And what's your common factor? Y squared. And pull out a y squared, you get a 3y minus 4. In the second group, yeah, the minus is already out there, pull out a 2, and then you get 3y minus 4. Hey, we got another common factor. 3y minus 4, pull that out, and you're left with y squared minus 2. Excellent. Same thing we got. Good for them. Any questions? Okay? All right. That was focus on factoring A and B on page 2, their solution on page 3. Then they got to check your understanding 2. 2 ones there, one A and B again. Do those as soon as you can out of class. Does anyone need to see any more done now? Okay. Then you got objective 11.1A practice problems. 5 of those, do those as homework. All right. I have a feeling that's the last slide. Oh, it is. Okay. So let's go through and start all this over again. 11.2A. No, wait. 11.1B. Sorry about that. Scratch that. 11.1B. I was going to skip the whole thing. No, we just did that. Sorry. I thought we had just done that. Okay, was there anything, I wasn't paying attention to the book. Was there anything here that we should have picked up on? I was talking about check your understanding, but I was on the wrong page. There is one, number 3. Ha! There is one. Okay. I hate to do this, but I really need to go back to the previous slide. Sorry about that. Well, I'll do it here. Y'all should follow in the book and keep me straight here. Did we do something like the top of page, module 11, page 4, factor y times x plus 2 plus 3 times, we did that, right? Or not? Did we do that? No? All right. Let's go back to, oh, this is still 1B. So let's go to it. Slideshow. Sorry about this. I get to running my mouth and I don't follow the book closely enough. Okay. No, we did not. Okay. Back when we were doing this, they had an example or a little thing, focus on factoring common binomial factor. Really simple. Y'all have already been doing it, but let me make sure that you've seen it. Okay. All right. Y times x plus 2 plus 3 times x plus 2. And y'all know what to do next. Tell me. X plus 2 times y plus 3. Okay. There's that one. Then there's a check your understanding 3. Do that shortly after class. Okay? And then the next one, this is the one that's very different. Okay, so I'm going to do that here. All right, this is one I wish I had seen earlier. 2x times x minus 5 plus y times 5 minus x. Uh-oh. Don't look like common factors, do they? Second? Commutative property. Okay. And addition and multiplication are commutative, but guess what? Subtraction and division are not. But if we were going to try to commute that, what would we have to do? Say again? Okay. I'll have a question for you. I'm going to write down the 2x times x minus 5, that's fine, plus y. Now, what if I factored out a minus 1? What does that do to the 5? Make that a minus 5. What does it do to minus x? Make it a plus x. Now that becomes 2x times x minus 5. And now I'm going to put the minus with the y, which is legal in most states, okay? And make it minus y. And now I'm going to rearrange those. Without anything else, what would that be? X minus 5. It's not exactly commuting, but it's like commuting, but you have to factor out a minus 1 to reverse it. And it's a subtraction. You have to pull out a minus 1 to reverse the order. If that was 5 plus x, yeah, just rewrite it as x plus 5. No problem. Because addition is commutative. Subtraction is not. So pull out the minus 1. That flips them, and then you have a common factor. What is that common factor? X minus 5. And what do you have left? 2x minus y. Okay. That one, they snuck by me. They didn't show on the slide set, and that was, I think, one of the more important ones to show. They didn't. There's also a check your understanding for it. Does someone need to see that again? Something like that? Are you okay with it? Y'all are easy. Okay. So, I think we did. Well, we didn't, did we? All right. Nope. Close, but no cigars. Okay. It's like that one, but not quite. 2x cubed minus 3x squared starts off the same way, plus 4x minus 6. Okay? What would you do for that one? Say again? Anybody? Group them, okay. Especially since that's the title of the section here, okay? Group those two, and since it's plus sign, group those two. Okay, what can we do with the first group? X squared times 2x minus 3. Next, plus 2 times 2x minus 3. And that becomes 2x minus 3, common factor, times x squared plus 2. Felt like we did that one, but it was close, but not quite the same problem. Okay? And then we did the focus on factoring, and we did those two. And then to check your understanding, that's after those. And then there were 5 homework problems. Please do all 5. They don't give you many in here, but they show you a solution to all of them. So please do those homework exercises. Okay, now we're through with the section. Okay? Now. Okay, now we're ready to discard. And now we're ready for 11.2A. All right. Here's one more thing about factoring by grouping. I think you probably already noticed it. When does that work? What is a minimum requirement to do a factor by grouping? Even number of terms in your, all the ones we've done with 4-term polynomials. Quadnomials, if you wanted to call them, or just 4-term polynomials. Sometimes you can do them with 6. With 8, you'll never do them with an odd number of terms. Unless you judiciously split one of the terms and get it to do that way. And usually that's not worth the effort. Okay, you can do it some other method. Okay, so let's continue with factoring polynomials and go from current slide. And now we're going to factor polynomials. I thought that's what, oh yeah, that's what we've been doing all along. And section 11.2 is factoring polynomials in the form of x squared plus bx plus c. Okay? That's often called a trinomial. Okay? X squared plus bx plus c. This is the easiest form of a trinomial generally to do. Objective 11.2A then will be factor trinomials in this form, which is exactly what the title was. Okay? So, here's what we're going to do. when did we wind up with this type of thing as an answer? What had we typically done right before that? We foiled it. We multiplied two binomials together with a power of exponent of 1 each, and then you got something that looked like that. Okay? So guess what we're going to do? Undo it. So I call it unfoiling. I've never seen a text call it that, but that's what I do. Okay? Now, B and C are integers. It just happens to be, in this kind, the first coefficient is always a 1, and these are so easy to do. Okay? But I want to show you the general technique. The B here, this one, x squared plus 9x plus 14. The B is 9, the C is 14. Wow, okay, I think I got that. Okay. Now. Second? Okay. All right. Trinomial expressed in product of binomials shown below. And what they're doing is showing you, they haven't shown how they factored it, but if they had it this, multiply it, FOIL it, you get this. X times x is x squared, plus 7x plus 2x is plus 9x plus 14. Yes, we understand that. Well, then you should be able to just flip it around, because it's still true, the other way. Now, they just showed you this. Here, I'm going to show you how I suggest you do it. You can do it any way you want to. Okay? I start with this. I unfoil. So, let me get my pen back. So, I start with my first term. I hope that this is factorable. They say it is. I believe them. What's the only possible factorization for x squared? X times x. Okay? Now, you're unfoiling. You would go to the, they gave outer term. I go to the last term. So I don't even spell it right. Okay? So I go to the last term, but not the whole last term, the sign of the last term. And what is that? Plus. What does that tell you about these two signs? They both got to be the same. So then we can look at the middle term to see what they got to be. Plus, plus. Okay? They got to be the same. That's all the positives there tells you. Then look at the middle term. So that's a plus and that's a plus. So what are we doing now? We want two numbers that multiply to be 14, but add to be 9. Right? What two numbers multiply to be 14? Oh, you looked, didn't you? You weren't supposed to look. Okay, no. It's 7 and 2. Okay, or 2 and 7. It doesn't matter the order. 2 and 7. And then, how do you check it? Refoil it. Just foil it again. X times x, x squared, plus 7x, plus 2x, plus 9x, plus 14. Yeah, got it. Okay. Now, they're going to show you something else, which works. It's basically doing the same thing, but I like to always start with the first term, even if it's that easy. Okay? So remember, the method by which the factors of a trinomial are found is based on FOIL. Hey, they're doing it sort of the same way, aren't they? The points to remember in factoring x squared plus bx plus c, in the trinomial, the coefficient of x is the sum of the constant terms of the binomials. The coefficient of x, oh yeah, I got it, yeah, of x. I was looking at x squared. Of x is the sum of, yeah, we just said that. Two numbers that add to b and multiply to bc. So yeah, that's exactly what we said. When the constant term of a trinomial is positive, the constant terms of the binomial have the same sign. They're not always positive, same sign of the coefficient of the middle term. If that's plus, they're both plus. If that's minus, they're both minus. If that last term is positive. And when the constant term of the trinomial is negative, then the constant terms of the binomial have opposite signs. And you don't know which goes plus and which is minus, but they do one or the other. I take it by all the noise I'm hearing that we must be running, sadly, out of time. Is that true? Oh, yeah, y'all said yes, it was sad. Okay, I heard you say that. Okay, well, you know your homework exercises. Where we'll pick up next time. Okay. We've just done the points to remember, but they skipped a bunch of other stuff. And let's see if they're going to pick up the other stuff. No, they're not. And frankly, Yeah, we'll do. We'll start with that stuff at the bottom of page 5 in section 11. Okay. What happens next time? Test on module 10. Okay? So everybody come prepared. What can you bring with you? Formula and equation sheet. Anything you want to write on a piece of paper, you can bring it with the test, to the test. And use it. Okay? All right. Any questions? All right, get your quizzes in. If you haven't already gotten them in, get them in today or tomorrow so I can get them back to you on Wednesday. Otherwise, come see your answers if you've already turned them in and I've already got them ready. Good deal.
Thank you, sir.
All right. You want to see yours? Let's see if I'll let you.
Sorry, I had to go to Fort Benning Friday.
What's that?
I wouldn't have to go to Fort Benning Friday.
Oh, you did? Okay, no problem. Are you in reserves? Are you in reserves?
I'm stationed at Fort Benning.
You what?
I'm stationed at Fort
Oh, you are? Okay.
I'm home for the surgery.
I see. Okay. Well, sorry you had your knee messed up, but I'm glad you could be here. Okay. Okay. All right. Andre? Right? Drew, I can't read. Yeah, I know, yeah. I'll let you see it. Don't run off without it. Okay. Keep these together so I will keep them together. Riley is not here, is she? That's great. You want to see yours? Now get them back to me. I can't leave these. Let these go. Agree with an E is not. Oh, you come from here. So video. Thank you. Cameron's not here. Okay. Got to keep these straight. Okay. You got it? Okay. Agree with an I. No. Letitia. Ariana. No, that's you. Here's Ashley. That's not you. Cynthia. That's not you. Juanita. I don't even remember that one. Kirsten. That's you. Huh?
Can you explain this to me?
You actually go to the
Okay.
This is for Christmas.
I was trying to figure out.
No, he wants to get married in March because we can't move out yet. After I'm not moving out until after I graduate.
I should have. Yeah, thank you. Oh, this is to be great. Keep those straight. I'll put it there. Okay. I didn't finish marking it. It's just that it wasn't.
I can't move out until I'm sitting there. Which is fine by me.
Yeah. 6 minus 2 would be 4x squared. So there's the correct answer. You had 8. You added it. Okay. And then 6 minus a minus 4, that adds to be.
He comes over to my house and my parents don't care because they said it's his mom that cares, but he's 24.
It should be a plus 10. I don't know where the 2 came from.
Parents rules.
Oh, no, I'm sorry. Minus 6 plus 4 is minus 2. And then you got
Okay.
the
And this gonna be on the test, right?
this hyper problem, not the same problem.
Yeah,
This
but
type, yeah, right.
okay. Thank you.
All right. All right, good deal.
I have trouble turning into English.
I'm sorry?
I have trouble turning into like your class, like in the book, because my first graduate.
Okay. Okay, I think your username is the same thing you use for your email and other stuff like that. Okay? Your institution, that's the number I gave you, which is, do you hear that, Dave?
Yeah.
Okay, Lawson.al 282748031. Okay, do you have that written out somewhere?
Yeah.
Okay, all right. And then, what's the last one? That would be, I don't know, did they give you one? Okay, well, I think you probably use whatever you use for your email or, see, I don't know what you use as a password. But your institution, that's the only thing I provide. And has anyone, have y'all done, well, gotten on Cengage Unlimited? Okay. Go find out from them what they put there.
Here, you have to make your account. You gotta just type in whatever you use for Cengage, and then when you pick, when it says institution, you put ours, and it'll let you connect everything. It's just linking. So you're gonna put a username and password, instruction, place, or loss of state, that's and then it'll just link everything. It's just asking permission to use your password. I recommend using the exact same one you log in just in case you don't forget. It's so much easier to get Absolutely.
Okay. I probably should have been listening in so I could answer that question again, but is it fairly straightforward?
Yeah, it's just, all it's asking is to verify. When it pulls that up, it wants your permission to link the assignment to the course.
Right.
So you have to put in a username and password, and frankly, I recommend using your Cengage username and password.
Okay.
And when it says instructor, it's just asking for which campus you're on, for the school campus. So you find Lawson, Bessemer, and all that does is you're giving them permission to link the material together because it's two different websites. It's Cengage and web, so you got to link them.
Why would they care which campus you're on?
Because if you're at the other school, then they might move a little faster or not, depending on the class, and it's all linked together. Because like when I pull up mine, I'm for yours. You're my teacher, whereas another teacher might be a little faster pace.
I see.
So they're trying to connect students' IDs with their logins, so they know I'm here, not over there pretending I'm here.
Okay.
Yeah, it's just technicalities.
Yeah.
It makes it a pain.
Yeah, it really sounds like it because I never gave them, so they must have somehow tied into our Blackboard.
Correct. They finally got it, the little quirks worked out, and the ones who get locked out have to call and get their IDs reset. I've had to do it 3 times now.
Yeah.
For different
I love WebAssign.
But it works wonderfully when it's working.
When it's working.
I mean, after the first few weeks, I love it.
Yeah,
I mean, it's like,
good to hear.
I finally found your class too.
Oh, okay.
It took me a minute to find WebAssign.
Oh, really?
Yeah.
Oh, his, it looked like it popped right up there.
Yeah, but it took me a good week to get there.
Wow.
Because
They probably had it
I had multiple logins.
Oh.
I had multiple IDs apparently because so many people tried to help me.
Right.
They made, I mean, it was like missing a dot or an S and just that little thing. They said there were 5 logins on each of my things.
Wow.
So I had to go back and they had deleted all of them. Right. So I just got into it last night.
Oh, wow.
So I got one done. I'll do the rest today, I promise.
All right, good deal. Thank you for your patience and your help.
Yes, sir. Oh, and by the way, the 0800 or the 080T, the course after this, is literally, for at least math, is nothing but tutoring hall. We just sit there, and they don't give us assignments. We have to just work.
Well, then you have.
Work at your own pace. The English one's a little different, but yours is just sit there and
just do your homework, do those things.
I always do.
Fantastic.
Home, so.
No wonder you're doing so well. Good deal. Sorry, I should already have been through with this. I had so many questions at the end.
Wednesday, I won't be here.
Okay, then you lose. No.
Yeah, I know. I tried to get the schedule where I wouldn't miss class, but
I know. Life gets in the way. That's fine. I'll try to record it. If everything's working, it'll get recorded.
yes, sir.
So I hope it will be working. So far this term, it's been doing well. And just recently they screwed up and didn't renew our contract. So we were out was that last spring or summer? Do you remember?
I think it was in the spring.
Spring, yeah. So we went for a few days with no access. And then there have been a few other times when other things have happened. All right. Now, let me go to exchange books. Oh, I've been recording all